Hi, welcome to Sachin Study Tech. Today topic is minimum coin change problem. So in previous video we have discussed about find a total number of ways you can make the change of given amount. So now we can discuss to find out the minimum number of coins to make change of given amount w equal to 11 using the given coins 1569. For example, I am using the greedy method. This is the minimization problem. You can find out the minimum number of coins to make 11. So it is a minimization. So minimization or maximization problem, you can use the greedy method and also dynamic programming approach. So in this example, you can discuss both the greedy method and dynamic programming approach. Then you can understand which is the better algorithm for this particular problem. So you can see I am applying the greedy method here. Greedy method. Greedy method says that if we can find out the minimum number of coins, so what is the maximum coin here? 9 rupee coin is there, so it can compare 11 greater than or equal to 9. So it is true, then remaining amount is 11 minus 9. You can require 2. You can require the 2 rupees. Now you can see here there is no 2 rupee coin. So here you have the only 1 rupee coin is there. So it is 2 greater than or equal to 1. That's why it is 2 minus 1. Here remaining amount is 1. You can require 1 rupee coin. So 1 greater than or equal to 1. Again you can take the 1 rupee coin. So that is 1 minus 1. That is 0. Now it can says that in greedy method it can says that. So I can take the 1 9 rupee coin and 2 1 rupee coins. Here this is the minimum number of coins is required to make the amount is 11 in greedy method. So you can use by using the dynamic programming approach. Here you can require only 2 coins, 5 plus 6. 5 plus 6, that is 11. So 2 coins are required. Here the minimum number of coins is 2. By using DP, dynamic programming approach, so this is the optimal solution. It is a optimal solution, but in this case it is not a optimal solution, but it is a feasible solution. Feasible solution may or may not be a optimal solution. So this is the example. It is a feasible solution, but it is not a optimal solution. Not a optimal solution. You can see the another problem. The coins are given 4, 10 and 25. Total amount is w equal to 41. Now you can use the greedy method here. Greedy method. I'm applying the greedy method here. Now what is the maximum coin here? 25. So 41 greater than or equal to 25. The condition is true. Now here it is 41 minus 25. That is equal to 16. That is equal to 16 here. So what is the next maximum coin is 10. So it can consider the next maximum by using greedy method. Here the 16 greater than or equal to 10. The condition is true. Then you can take that 16 minus 10 here. The remaining is, you can require the 6. But 6 rupee coin is not there here. So the minimum coin here it is 4 rupee coin is there, but it cannot make a 6. So it cannot provide the solution. So by using greedy method there is no solution for this particular problem, but solution is existed. So by using dynamic programming approach, the solution is, that is the optimal solution here. It is 25 rupee coin and 4 coins, 4 rupee coins 4 I am considered here. That is, it is a 16 plus 25, that is 41. The solution is existed. So here the minimum number of coins is required. 5 coins is required by using DP. But in greedy method there is no solution for this problem. So now we can discuss dynamic programming approach here. But find out the minimum number of coins to make the change of given amount w equal to 11 using the given coins 1569. So recursive solution, that is without memoization technique. What is the time complexity is big of amount power n. N is the number of coins. So amount is the total amount. So space complexity is big of amount. So without using memoization technique means, so what are the sub problems is there? That sub problem is solved more than once. The same sub problem we can solve more than one time. So without memoization technique. So that the time complexity is increased. So you can see here it is 11. The total amount is 11. I am consider the coins. Here it is 1 rupee coin is there. So 11 greater than or equal to 1. The condition is true. So 11 minus 1, that is 10. Here it is, next coin is 5. Here it is 6. Recursive call, here it is 9. So here it is also 11 minus 5, that is 6. Here 11 minus 6, that is 5. Here 11 minus 9, that is 2. Here also you can divide. Here it is 1 and 5 and 6 and 9. So here it is 9, 5, 10 minus 6, that is 4. Here it is 1. So 1 rupee coin, it is a small problem. Again here is also divided into, so likewise 1, 5 and 6 and 9 also. So like that you can expand this entire tree here. So by using greedy method without using memoization technique, so the time complexity is more, because the same problem you can solve more than one time. The same problem you can solve more than one time. So that is the problem here. So here it is there 5, 10 minus 5, 5 is there. Here also 5 is there, like that. So more than one. Here also, for example, 9 plus 5, 4 is there. Here 4 is also there. So you can solve more than one time the same sub problem. So without using memoization, that's why the time complexity is increased. Now using memoization, so what are the sub problem solution is there? That sub problem solution is stored in table. Whenever you can require that sub problem solution, you can take the directly that value without solving the same sub problem more than once by using memoization technique. So here also you can find out the minimum number of coins. This is the algorithm. This is a simple code. You can see here it is. Here it is. Row indicates the I and the column indicates the J. Here it is W. Here it is coins. So I value is 0, I value is 1, I value is 2, I value is 3, because here 4 coins is there, 1, 5, 6, 9. So 1 rupee coin is there, 5 rupee coin is there, here 6 rupee coin is there, 9 rupee coin is also there. So the problem is W equal to 11. That's why the problem is a big problem. So the problem is divided into sub problems. You can solve each and every sub problem. Ultimately can get the final solution for that big problem. So what are the solution is there? Sub problem solutions, you can store it. Whenever you can require the same sub problem, you can take that value directly, that solution. So here it is A of I0 equal to 0. That means I value is 0 or I value is 1, I value is 2, I value is 3. So the J value is 0. So here it is 0. So that is A of I. So A of I is 0, 0, 0 is 0. Here it is also 1, 0 is 0, 2, 0 is 0, 3, 0 is 0. Otherwise, so you can take the 0 here. So how many minimum number of coins to required to make the 0? So 0 coins is required. So that's why you can take the 0 coins. Here it is 1. How many number of coins is required to make the 1? By using this one. By using this one, only 1 coin is required, 1 rupee coin. Here it is how many ways to make this 2? By using 1 rupee coin. 2 1 rupee coins is required, 2 coins is required. Here 3 1 rupee coins is required, 4 1 rupee coins to make the 4. Like that, here 5 6 7 8 9 and 10 and 11. 11 1 rupee coins is required to make the 11. So now we can consider the, you can row is incremented here. Then you can include 1 and 5. What is the minimum number of coins? So here it is, you can see coins of I greater than J, coins of I greater than J. Then you can take the previous value, that is A of J equal to A of I minus 1 j. So you can see here, here it is coins of I, and coins of 1. Coins of 1 value is 5 rupee coin. Here it is 5 greater than, what is the j? J value is 1. J value is 1. Condition is true. Like that, here up to this point, 5 greater than 2 condition is true, 5 greater than 3 condition is true, 5 greater than 4 condition is true. Okay, 5 greater than 5, the condition, the 5 greater than 5, the condition is fail. So up to this point, so you can store the previous value, that is a of, for example here I value is 1, here it is I value is 1 and j value is 1. So here it is a of 1 1. So I am right here a of 1, j value is also 1, and a of I minus 1, that is 1 minus 1, a of 0, and a of j, that is 1. So a of 1 1, you can store the value a of 0 1. A of 0 1 value is 0 row and first column, so 1 is there, so you can store 1 here also. So that's why 5 greater than 4 up to this point, you can, what are the value is there in previous row, that value you can take directly here, because here you can take the 5, but 5 is not included because it is a denomination, so you can require the 4, but that's why you cannot include this coin. For example, this condition is fail, 5 greater than 5, the condition is fail here. Now, so I can calculate the value, else block is executed in this case. Now what is the I value? I value is 1 and j value is 5. So j value is 5. So this is I and this is j. So else block is executed. So else block a of ij. So I value is 1, a of j, j value is 5 here. It is minimum of a of I minus 1, that is 1 minus 1, that is 0. Here it is j value is 5, a of 0 5 comma 1 plus a of 5, 1 plus a of 5, a of 5 value is a of 1 and j value is 5. So 5 minus coins of 5, coins of 5 means coins of 1, that is 5. This is 5. So what is the value here? Minimum of a of 0 5. What is the 0 row and fifth column here? It is 5. A of 0 5 is 5. So 5 comma 1 plus a of 1. Here it is 0. 5 minus 5 is 0. So a of 1 0. So first row and 0 column. That is 0. Here it is 0. So minimum of 5 comma 1. So what is the minimum value? 1 is the minimum. So that's why you can take the 1. So latter cases here directly can write here. Simple technique here it is. For example, to make the 6. So here it is previously 6 1 rupee coins is there. So 6 coins is required. But I am including the 5 plus 1, so 6 rupees. So to make the 6, so this is the 1 coin, this is the 1 rupee coin, 1 5 rupee coin, 1 rupee coin, that is 2 coins are required, minimum coins. Here the 7, so 5 1 rupee coin, 1 coin is required and 2 coins 1 rupee coins is required, that is 3 coins is there, 2 coins is required, 1 5 rupee coin, 2 1 rupee coins. So here it is 8. 8 means here 1 5 rupee coin, 3 1 rupee coins. That is 4 coins is required to make 8. So here it is 9. 5 1 rupee coin and 4 coins for 1. 1 5 rupee. So that is, this is 4 plus 1. That is 5 coins is required to make the 9. Here it is 5 rupee coin and previously it is 9 coins is required to make the 9, because you can take 1 rupees. So here you can consider it is a 9, that is you can consider the 5 plus here it is 1 coin, here it is 4 coins, that's why here it is 5. Now you can see 10. So 2 5 rupees coins, 2 coins is required to make that 10. Here it is 2 5 rupee coins plus 1, that is 3 coins is required. 3 coins is required here. It is, here you can see, so 6 up to this point. You can take the previous value, here it is 1, it here 2 and 3, previous row value here at 4, here the 1. Here for example you can include the 6, so 6 rupee coin, so 1 coin is required to make the 6, 1 coin. So next 7 rupee coins is required, so 7 rupees required, so 1 6 rupee coin, 1 rupee coin, that is 6 plus 1, that is 2 coins are required. Here it is 8, that is 6 1 rupee coin, sorry 6 rupee coin, here 1 6 rupee coin and 2 1 rupee coins. So here it is 2 plus 1, that is 3 coins is required. So 6 plus 1 rupee coins 2, that is 3 coins. The 9 means I can consider the 6, 1 6 rupee coin, 3 1 rupee coins, that is 3 plus 1, that is 4 here. It is 10, here it is 6 plus 4, 4 coins, this is 1 coin, that is 5 coins is required. Otherwise you can see here it is 5 rupee coin, here also 5, we can require that 10 coins, but here it can take the 5. But you can see here the 10, here the 10 you can require 2 5s, 2 5 rupee coins to make the 10, so you can take here 2, so it is 9, so that is 6 plus 3 coins, so that is 3 coins 1 coin, and that is 4. Now we can see here it is 11, so 1 5 rupee coin, 1 6 rupee coin to make the 11 here, that is here is also 2. So up to 9, here it is up to this point, what are the value is there in previous row, you can take directly. Here it is 3 and 4, minimum number of coins 1, here it is 1, here it is 2, here it is 8, sorry here it is 3, here it is 3. Now you can see here it is 9, 1 coin is required to make the 9, so 9 rupee coin I can take. So here it is 10 rupees, so I can take 1 9 rupee coin, 1 rupee coin, that is 10, that is 2 coins is required, or 2 5 rupee coins, it is also 10, so minimum 2 coins is required. So 11, so 11 is 9 plus, here it is I can consider 2 1 rupee coins, that is 3 coins is required. For example 6 plus 5 11, so 2 coins is there, so the minimum coins are 2, so I am consider here 2. So this is the solution. So to make the 11, 2 coins are required. What are those coins? How can find out? So 2 is there, here 2 coins are required. If you can include the 9, you can get the 2 coins. You can see previously 2 is there or not, you can check. Previously 2 is there, so this 2 is because of not including 9, so that is this row. So here it is 2 coins is required. What are those coins? So here it is 1 6 rupee coin, here it is I am consider 1 6 rupee coin, that is 11 minus 6, 11 minus 6, that is 5. You can see here it is in fifth column, you can see in fifth column 1 is there here, so here 1 is there because of 6. Here you can see the previously 1 is also there, so there is no 1 here. Then so 1 5 rupee coin, 1 5 rupee coin, 1 6 rupee coin, so that's why. So 5 plus 6, you can get the 11. So these are the minimum number of coins. 2 coins is required, 2 coins is required. This is the problem. Top down approach dynamic programming memoization technique you can use. The time complexity is big of n into amount. Space complexity is big of amount plus n. So space complexity here it is for memoization technique, and you can use it, and recursion stack plus recursion stack, that's why it is take the n. So the space complexity is big of amount plus number, n is the number of coins. So this is the example problem for dynamic programming approach. So minimum number of coins you can find out by using dynamic programming approach. Thank you for watching this video.